All right, welcome. So, have you ever wondered how we get such fast Wi-Fi or why your 5G signal is so clear even when you're in a super crowded place? Well, a huge part of that magic is this really clever technique called orthogonal frequency division multiplexing. Yeah, it's a mouthful, so we'll just call it OFDM. Let's break down exactly how this thing works. Okay, so here's the big problem that engineers are always trying to solve. The airwaves, right? The radio spectrum. There's only so much of it. It's not infinite. A good way to think about it is like a highway. You want to pack as many cars on it as you can to get everyone where they're going, but you can't have them crashing into each other. For us, those cars are data streams. So how do you pack more and more data into the airwaves without causing total chaos? Well, you guessed it. The answer is OFDM. But what even is it? And what's the big deal? What makes it so special? Come on, let's take a closer look.
So, at its heart, OFDM is just a really, really smart way to send digital information. See, instead of trying to blast one huge, super fast stream of data on a single channel, it does something different. It takes that big stream and it splits it all up into a bunch of smaller, slower streams. Then it sends all of those out at the exact same time, but on many different frequencies that are packed incredibly close together.
And that right there is what makes it so powerful. It's all digital, which is great, but the real key is that it's a master of multitasking. It's sending tons of signals all at once over the same link. That's why it's the go-to technology now for pretty much all high-speed data. Your Wi-Fi, your LTE, your 5G, and that multitasking, that's exactly why your phone still works when you're at a packed concert or stuck in a busy airport.
Okay, to really appreciate just how cool OFDM is, it helps to look at what came before it. Let's compare it to an older method called frequency division multiplexing, or FDM for short. And this visual just nails the difference. Look at the top graph. That's the old way, FDM. See those big empty gaps between each of the colored signals? Those are called guard bands. They're literally just wasted space, put there to make sure the signals don't bump into each other and cause interference. But now, look at the bottom graph. That's OFDM. Whoa, the signals are squeezed right up against each other. They're even overlapping. This is so much more efficient. It's like adding new lanes to our radio highway. But wait a second. If they're overlapping, how on earth do they not interfere with each other? Shouldn't it just be a chaotic mess? Well, that brings us to the secret sauce, the magic trick, really. It's a brilliant mathematical concept, and it's called orthogonality. Now, orthogonal sounds super complicated, but the idea is actually pretty simple. It just means that the signals are set up in a very special way so that they act independently. Even though they're all mushed together, they're designed so that at the exact moment you're trying to read the data from one signal, all the others are basically invisible. They have zero effect. It's like they're not even there. Okay, let's see this in action. Take a look at the image. Let's focus on, say, the pink wave. We want to read its data. So the receiver is going to look at it right at its peak. You see that? That's where the signal is the strongest. That specific point is the frequency we're tuning into to get the data for that particular stream. And here's the magic. At that exact same spot where the pink wave is at its peak, look at the other waves, the yellow and the blue one. What are they doing? They are perfectly crossing the zero line. Their value is literally zero right at that point. So they contribute nothing to the signal we're measuring. It's like they're completely silent. Zero interference. And this isn't a one-off trick. This is designed to happen for every single one of the signals. It is just an incredibly elegant solution. Okay, that's amazing for sending the signal. We've packed all these waves together and shot them through the air. But what happens on the other end? How does your phone or your router take this super complex, jumbled up wave and actually figure out what the original data was? Well, this is where the receiver's demultiplexer comes in. It uses that same orthogonal feature to work its magic. It basically uses a super fast mathematical process to look at the whole combined wave. And because of that amazing zero crossing trick we just saw, it can tune into each specific frequency, find the peak of the signal it's looking for, and completely ignore all the others. It does this for every single stream, pulls them all apart perfectly, and then stitches them back together into the original, complete, high-speed message. It's pretty incredible. And there you have it. That's the core idea behind OFDM. By cleverly, and I mean very cleverly, overlapping signals without them interfering with each other, we make our airwaves more efficient than they have ever been. This is the technology that's literally powering our modern wireless world. So it makes you wonder, right? Now that we have this incredible capacity to send data so efficiently, what kind of amazing new things will this technology unlock for us next?